Hello all. Today we are going to see about the dimension of the V1 block which is manufactured by IIW, Internal Institute for Welding. This is the V1 block that you see here. This thickness is 25 mm and this total length is 300 mm, and you can see glass here which is called as a plexiglass. It's 23 mm. This is flush with the material here, and this side 2 mm is taken out so that its thickness is 23, and this right here is 200 mm and the overall dimension for this is 100 mm. This radius right here is to 100 mm and this one is 25 mm. It's like a groove shape. You can see this one. And we have also a side drill hole here which is 15 mm from the top, and from the side it is 35 mm. So right now we are going to see the calibration of a normal probe using V1 block. This right here is the ultrasonic flow detector which we are going to use for this calibration. This model is Sonic Einstein 2 DGS. It's an Indian make model. We are going to see the calibration of a normal probe, which is a 10 diameter crystal, 4 MHz frequency, using V1 block. We are going to connect the probe using a BNC connector and a LEMO cable. We have two ports right here. One is for the transmission, one is for the receiving, and here is a charging port. Since we are using a normal probe, we can use a single wire which acts as a transmitter as well as a receiver. Okay. First we are going to connect this probe and then this cable with the probe right here. Okay. As you can see, this is the ultrasonic flow detector Einstein 2 DGS. We have 11 menus, a total of 11 menus. You can see here, menu 1, 2, 3 up to 11, and this right here, the green color line you see, this is called the gate. We can reduce the gate, increase and decrease the gate also. This serves as a purpose for detecting the size of the indications or cracks or anything, or the dimension you can see by using this gate. We place this gate on the echo to see the signal here and here. You can change the menus according to your preference. When you are using an angle probe, you can use this. Using a normal probe, you don't want this, you can switch it off, since we are going to see only the depth here. If you are going to use angle probe, this is a must. Then this option right here is gain, which is going to increase the amplitude of the sound waves which travel from this crystal to this block. This right here is the zero of the probe. We have to calibrate this to 25 mm, which is a known thickness, so that we get 4 backward echoes properly. Once we calibrate this, then we can do the inspection. This is the velocity for steel, which is 5920 meter per second. Then the range I have set is 105 mm because I am going to set 4 backward echoes, which is 25, 50, 75 and 100. So I have just put 105 mm instead of 100 so that I can see the backward clearly. So I am going to start calibrating here. Before that, I will check the menus first. If there is anything wrong, we can change it right now. The mode has to be single, since it is a single crystal probe. Then you can see everything is 0. Since we are not using angle probe, we are using only a single crystal probe. Everything is 0. Then that's it. Let's start. Okay. First we have to put a couplant. I am going to use an oil only, just 2T oil, normal motor oil. You can use water, glycerin, anything. Now we are going to calibrate the 10 diameter crystal 4 MHz frequency transducer using the V1 block right here. I have already applied the couplant. I have put oil, 2T oil, motor oil. So first what I am going to do is place the probe on the V1 block. I am getting 4 signals, which is the backwall echo. What do you mean by the backwall is the sound waves go and touch the bottom and reflect back. That signal is called the backwall echo. So right now I am going to be placing the gate right here to see the depth which is showing 19.3 mm. I have set the unit as metric. So you can see in this menu number 8, unit is metric. If you want, you can set inches according to your preference. So I'm getting 19.3 mm. I know this value is 25, so I'm going to set the probe 0 to 25 mm. I'm going to adjust the probe 0 so that I'll get 25 mm as my first back wall. This key right here is called the hot key, or which is used for moving the this key right here is the hot key, which is used for moving the values faster, much faster. So I'm going to set this back wall at 25 mm. Already it's 26. Since we know the thickness of the V1 block as 25, I'm going to set this as 25 mm. I'm getting 24.3, so I'll adjust a little bit more. 24.6, 25, 25.2. There will be a deviation which is mentioned as a tolerance in the standards. I'm getting other three back walls, which is at 50 mm, 75 mm and 100 mm. You can check this using the gate, moving the gate to the second back wall. You see the values right here, 50, just a minute, and this one you can reduce your level, check it, which is 75, and the last back wall echo, I'm going to place this right here. Okay. So I'm going to reduce the level right here. See, it is showing as 101.2. That's okay. This is the normal calibration using a V1 block, but there are several steps to it, like checking the vertical linearity, resolution, sensitivity, and so on. So let me do the resolution check right now, which is, as you can see, this is the notch right here, 5 mm gap. So I'm going to be placing the transducer on top of here, right here, to get this signal in my screen, which will be somewhere under here. As you can see, it is 84. This value right here is this dimension is 85 mm, and this one is 95, 91, and this last one is 100 mm. So I'm going to apply a little more couplant here and place the transducer right on top. As you can see, I'm getting 3 echoes in my CRT screen, so I'm going to increase my amplitude a little bit, and I'm going to adjust my gate. So the first first echo I am receiving is 85.6, which is right, this one. This is the first echo, and the second one that I am getting is 91, which is this surface right here, and the last one is 100 mm, which is the back wall of this material. This is what we call as resolution check, and right now I'm going to perform another one, which is called as sensitivity calibration, using this side drill hole right here. I have to catch this hole to check whether I'm getting 15 mm from the top, and from here 35 mm. If I'm getting it, then probe is sensitive enough for calibration for inspection purpose. Okay, I need a little more couplant here and on the side as well. So let me check if I'm going to get a signal right here. Okay, I'm receiving 2 signals, this one and this one. This signal is for the plexiglass, which is the sound wave sitting right here, and the one I'm getting near the initial pulse is the signal for the sidal hole, which is 15 mm, so it will be very nearer to the initial pulse. You have to calculate it precisely. So I'll reduce my gain a little bit, place the gate. is 14.7 mm, which is the first sidle hole signal, and I'll place right here to get the 35 mm signal. Yes, I'm getting it. And move the gate, also increase the gain value. I'm getting 34.8 mm. This is how you check for the sensitivity calibration. And the last step that I'm going to be doing right now is, it's not the last step, there's one more step. What I'm going to do right now is calibrate this plexiglass to the required velocity. We should not adjust the probe 0 right now since it is already set to 25 mm. We should just calibrate the velocity of this plexiglass. So I have to check, I should get 23 mm, so I should change the velocity to that. I'm getting a backhaul right here, so I'll place my gate and check. I'm getting 50 mm, so I'll reduce it. Okay, I have to move. Okay, right now I'm going to calibrate for the velocity of the plexiglass. So I have to move my velocity, change my velocity to the plastic velocity. It's almost around 2800 mm, 2800 mil. Right now I am going to do the velocity calibration for the plexiglass, which is in the V1 block. We know the dimension has 23 mm thickness, so I am going to be adjusting the velocity for the plastic, which is almost 2800 meter per second. Let me move my gate a little bit to the front. Okay. I'm getting 23.5 as my reading right now. Let me see if you can adjust a little bit more. Go to the first menu and start adjusting my velocity once again. Yes, right now I'm getting 23.1 mm. This is absolutely fine. This is the velocity for this plexiglass, and there is also one more step. Okay, right now I'm going to do the calibration for amplitude control linearity, which is for the checking the gain. Right now I'm going to set the first backhaul echo to 80% full screen height. As you can see here, you get the echo percentage right now. And the second backhaul will be automatically set to 40, and this third one 20, and the last one as 10%. This is the dB step. I'm going to set as 6 dB, as you can see, 6 dB, and decrease once we get 40% height. The second backhaul reduces to the say 20%, and the third one as 10%, and the fourth one as so on. Then we have to reduce this once again. We get 40% will be reduced to 20% height, and then we have to make the dB step to 12 dB to make it as usual, as it was in the first place, 80% full screen. This is called amplitude control linearity, which is one of the steps in calibration of a V1 block.